Welcome back to Geometry Classroom. Today we'll learn and we talk about similarity of triangles. In this lesson, we'll define similarity. We'll learn about cases of similarity, and we'll use these cases to find missing sides. Now, let's define similarity. Two objects or two figures, geometric figures, are similar if they have the same shape but different size. Remember, when we talk about congruency, we learn two geometric figures are congruent if they have the same shape and the same size. But this time, the only thing that is the same is just shape. When we talk about similarity, the objects have different size. Like in this case, as we look at these two cats, right? They have exactly the same shape, but different size. That's why they are similar. We use a symbol for similarity, and this symbol is written here. Yeah, this is the symbol for similarity. Good. Now, let's move to another slide. We have a definition for similarity. We say two triangles are similar if and only if the corresponding sides of one triangle, the corresponding sides of the triangles are in proportion and their corresponding angles are congruent. If we look at this diagram, right, these two triangles are similar if and only if the corresponding angles, which are A and D, are congruent. Then B and E congruent. Then C and F congruent. Besides these conditions, the corresponding sides of these two triangles must be in proportion. What does proportion mean? A proportion, as we know from a previous lesson, is an equation that states two or more ratios are equal. Now, so how we write the ratios of the corresponding sides? We, because this triangle is the first triangle, all its sides would be on top of the ratios. Remember, a ratio is a fraction, has a numerator and a denominator. Good. Now, the sides of the first triangle must be on top of the fractions or of the ratios. The sides of the second triangle must be in the bottom of the fractions. So, what is the first ratio? The first ratio is AB over DE. Why? Because these two sides are corresponding. Yeah? So, this is AB over DE. Then, the second pair of corresponding sides are BC, right? And EF, right? And the third pair is AC and DF, right? Now, if all of these ratios are in proportion or are equal, and these corresponding angles are congruent, then we can say triangles ABC and DF are similar. Now, let's move to another slide. Look, as we had for congruency, we have something similar here. Remember, in order to prove two triangles are congruent, it's not necessary to prove all parts, corresponding parts, are congruent, right? Just a combination of parts. So we have something similar here for similarity. Yeah? In other words, there are this time 3 accepted methods or cases for proving triangles are similar. First case is so-called AA. A, remember, comes from word angle. In fact, each of these A represent a pair of corresponding angles, right? So, what does this case state? If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Look, in this case, angle A congruent angle D. They are corresponding and congruent. Then angle B congruent angle E. They are also congruent. So if these two conditions are true, yeah, then triangles ABC congruent triangle D, similar triangle DEF. That's the first case of similarity. Another case, the second case, is so-called SSS. Remember, we had also the same name for congruency case of triangles. But now, be careful. SSS has different meaning here. It's not the same case as SSS for congruency. Why? Because this time, there's the corresponding sides of the triangles must be in proportion, not congruent, as we had for congruency. So, S, as you know, comes from side. In fact, each of these S represent a pair of corresponding sides. Yeah? What does this case state? If the 3 sets of corresponding sides of two triangles are in proportion, then the triangles are similar. Good. Now, when you have such a case, we have to identify the corresponding sides and then write their proportion, their ratio, and make a proportion. Good. So, what is the corresponding side for AB? Is D. For BC is EF. For AC is DF. So, we have to write the ratios. Now, remember, because this triangle comes first, its sides must be on top of the ratios. And the sides of the second triangle must be in the bottom of the ratios. Yeah? So, as we can see there, AB is right here. Yeah? DE, which is the corresponding side for AB, is in the bottom. Also, BC and DE. BC is on top, and EF is in the bottom, and so on. So, if this statement is true, in other words, if the corresponding sides of one triangle is in proportion with the corresponding sides of the other triangle, then triangles are similar, right? Good. And the last case of similarity is so-called SAS. Yeah? Again, despite we have the same name as SAS for congruency of triangles, SAS has different meaning here, right? Now, as we see here, again, the order of letters matters. As we can see, again, the angle, is included by sides. In other words, the angle we are looking for is included by sides of the triangles. Good. So what does this case state? If an angle of one triangle is congruent to the corresponding angle of another triangle, and the lengths of the sides including these angles are in proportion, then the triangles are similar, right? Now, look at these two triangles. They are similar if and only if these two angles, A and B, are congruent, yeah? Because they are corresponding. And the included side, or the sides that include these angles, are in proportion. Now, the corresponding side for AB in the other triangle is DE. Yeah? And the other side that includes the angle is AC for this triangle, and DF for the other triangle. So we write their ratios. Their ratios is AB, right, over AB over DE. Remember, the sides of the left triangle are always on top. The sides of the right triangle are in the bottom. Good. So AB over DE equals, right, AC over DE, DF. Yeah. So if these two statements are true, then based on SAS, the triangles ABC and DF are similar. Good. Now we have two practice problems with similarity of triangles. One more time. So, in both cases, we assume the given triangles are similar. Because they are similar, we know for sure their corresponding sides are in proportion. Now we have to write their ratio and make them equal. Now, what is given here? This triangle comes first. This is next. Now, which means the sides of this triangle must be on top of the fractions. The sides of the second triangle must be in the bottom, right? Don't forget. So let's write the ratio, their ratios. Now, what is given? Is given side UT. Side UT equals 26. So is on top. Over. Now, we have to find the corresponding side of UT in the other triangle. Now, how will you find the corresponding side? By looking at the place of the letters. The corresponding side for UT in the other triangle would be BA, right? Because the corresponding letter for U is B, the corresponding letter for T is A. So the corresponding side is AB. AB is 39, so we'll go in the bottom of the fraction. Good. Equals, remember, they are in proportion. We have to come up with another ratio, because our goal is to get this side. We don't know, we have to find out. Now we look at UC. UC equals X, because UC belongs to the first triangle, x will be on top of the fraction. Good. Now we have to find the corresponding side of for UC in the other triangle. Now, again, we look at the letters. So, CU is corresponding to CB. Yes? Why? Because C is in the place as the same, C, and the corresponding letter for U is B in the other triangle. So, the corresponding side is CB. How long is CB? CB is 27. So, we have a proportion. How we solve proportion? By cross multiplication. We multiply diagonally, right? So, we multiply 39 by x, right? And then 26 by 27. Because these two products are equal, we put an equal sign between them. And then we solve for x. How? We get rid of 39 by dividing by 39. So these two divide out, so was left x equals. Now, it's hard to figure out how much is, but we can simplify this fraction to make our computations easier. Now, 27 and 39 have 3 as a common factor. So, if you divide 27 by 3, you get 9. If you divide 39 by 3, you get 13. Good. Now, 26 and 13 have 13 as a common factor. So, if you divide 26 by 13, you get 2. If you divide 13 by 13, you get 1. So, next, we multiply the remaining numbers, which is 2 times 9. So, x would be 2 times 9, which is 18. So, we found x. Now, another example. This time, we have these angles. We need this side, PR. Again, because triangle PRQ comes first, its sides would be on top of the ratios. Yeah? So, we write two fractions first. Yeah? On top of each fraction are the sides of the first triangle. Now, let's start with PR, which is x. We put it on top. Now, in the bottom of the fraction should be the corresponding side for PR in the other triangle, which is how we identify the corresponding side by looking at the names of the triangle. So, we have P and R. What are the corresponding letters for P and R in the other triangle? R, M, and K. Which means the corresponding side for PR in the other triangle is KM. And KM equals 182. So 182 is in the bottom. Next, what else is given in the first triangle? Is given RQ, right? So RQ, which is 60, would be on top of the second fraction, is 60. Good. Now, we have to identify the corresponding side for RQ in the other triangle. Again, we look at the place of the letters. So, RQ is right here, right? What is the corresponding side for RQ in the other triangle? Is KL. But KL is 168. You put in the bottom. And then we start solving for x. So, again, cross multiplication. So, you're going to get 168 times x equals 182 times 60. Then we get rid of 168 by dividing by 168 both sides. These two divide out, remain x equals 182 times 60 over 168. Good. Now, it's because we deal with large numbers, we simplify. Now, if you look at these two numbers, yeah, I think the largest common factor would be 12. Yeah. So you're gonna get 5 here, and here you're gonna get around 14. Good. Then we look at 182 and 14. The common factor, the largest common factor for these two numbers is 14. So if we divide 182 by 14, you're gonna get 13. And here you get 1. So we simply multiply the remaining numbers. 13 times 5, which is 65. So length of PR would be 65. Thank you for watching my video. So this is all we have for today. We'll see soon with another topic. Stay safe. See you next time.